Good day. In this session, I am going to explain and run a code for image classification using CNN and sequential model, and I will access the TensorFlow library. Okay, so to start with, uh, I have already prepared my dataset for this demonstration. First, we will have make sure that you have training and testing datasets. Okay, in this case, in this image classification, I will do uh, facial recognition, okay, for three faces or three persons. Okay, so uh, if you see, I have divided the datasets training datasets with three classes named. For each class, I have one folder for Glenn, Isaac, and Armin. And in each class or each folder, I have acquired 64 images. Same with other folders, random images, facial images. And uh, in my test folder, test images, I have 20 20 images per class or per folder. Okay, and then after you have accumulated those images or datasets, you have to uh, compress them into a zip file and then upload it to your G drive or Google Drive. So like mine, notice. And then in your Google Colab, Google Colab notebook, okay, make sure that you have mounted the G drive. Okay, so that prerequisites, if that is complied already, then let's move on to our codes. First off, okay, let's import the TensorFlow. And by the way, the version of my TensorFlow is 2.8. Okay, as you can see. The next is we have to import the libraries that is needed. And in this example, we are using TensorFlow Keras, okay, and the others. Okay, let's import them. And then after that, no, let's create images with white backgrounds. Those codes, and then we have to install the Pi drive, okay, in which it will establish a link or connection to our Google Drive. Okay, and then after, so we have to authenticate the user. You just click allow, then yeah, just click allow. All right, next is to access the zip file which contains my datasets or my images for this session. Let's access them, locate them. Okay, getting the keys, and let's unzip the zip file. Right, as you noticed, it is inflating or extracting the images in my zip file. And then let's create a path. So uh, this path now will look up to the contents of the folder. And then let's check what's inside what are the folders inside the dataset folder. Okay, and so we have train and test, and then after that let's just create variable as directory for uh, fetching the path of those folders inside my Rito main folder. And then after that, let's create training and for testing directories, right? Then after that, let's just check the length from the train length directory, the length of uh, the length or the number of images inside that directory. Yeah, 64. So, and then let's trim down, or uh, let's do cropping of images into equal sizes or equal dimensions. So by the way, the batch size, it will be used later for the training. Okay? And later I will explain what is the batch size. Then yeah, let's generate the image. Then let's do this. Let's just create a um, let's just do the generation of the training set, okay, from the directory. Okay, so let's just do this. Then, so if you notice, we have found 192 images belonging to three classes, because as I mentioned a while ago, for each class one folder, it contains 64 images. Okay, so 64 times 3 is equal to 192 images. And then let's do again categorical mode of creating classes. Right, so found 60 images belonging to three classes. Let me run it again. Right, and then after that, let's create a variable for generation of the next training data generation. Then this function, as described, will plot images in the form of tree. One row and five columns where images are placed in each column. So in this example, I'm just loading three images, random images from my data sets. So let's plot the images. Alright, so those are the sample images. If I load it again randomly, okay, let's just wait. Alright, and then next after that, let's load uh, the CNN sequential model. So if you notice, you have here hidden layers. Okay, and at the end, in the dense layer, I have chosen 512 for ReLU, and I have put 3 for softmax. So this means I will we expected 3 classes, okay? 3 classes as output, since we have in 3 classes as input. So in the same way, the output should be also 3 classes. Then after that, let's the optimizer we are using is ADAM, and the loss categorical in cross entropy matrix is we are trying to find the accuracy. And then let's check the model summary, right? So you just display the model summary. So next, batch size and epochs. So batch size, we choose 32. Okay, 32. So this means there will be 32 images per batch, or I mean 32 images per cycle of training. Okay, per cycle of training. So because we have 192 images in our data sets, So if we divide it into 32, so we expect to have six six iterations per batch. Okay, six iterations per batch. So later we will look at it, how the iterations works, in training per batch. Okay, and the number of epochs, or the number of the times that for training will take 20 epochs. Okay, let's just set that, and then okay, let's just create storages or variables for training, and then so let's let's use the model. So this is intended for validation and for callbacks during the training. Right. So as you notice, so this is what I have told you about, uh, what we have set above. So we have 20 folks, and then as you see, six iterations per batch because we have 32 batch size. Okay, we have set 32 as batch size, where in fact we have 100. If we just recall, we have 192 images. 192 images divided by 32, so therefore we have six iterations for each batch. So for this, so because it will take 20 epochs, this will take much time, so therefore I will just pause this for a while, and then let's continue to record. I will continue to record the screen once the training is done, training and the validation. Okay, so if you can notice, okay, so it will start in the first, second to fifth epochs. So the validation accuracy uh, will be will be less, or it will not generate a high accuracy. Okay, so let me just allow me to pause this recording, and let's go back after. Okay, so we are now in our 11th epoch over 20. So as you see, our validation accuracy are getting higher, are increasing. Okay, so let's continue on our recording. So if you notice, so we have already high accuracy for our for this is for our training. If you notice, for our the model is able to arrive at 0.95 accuracy for the training datasets, while for the validation accuracy using the test or validation datasets, it is perfected, or it has gone 100%. Okay, so yeah, if you see at the 17th to 18th to 19th epoch, we reach a high value for our validation accuracy. So this means that uh, the model is outstanding, or performed well, or has performed well. So just finish the all right. So 20th epoch has been finished. So let's check. Alright, so the accuracy for the training datasets reach 100%, for the validation accuracy, or for the validation datasets, it has reached 96% or 97%. Okay, now let's plot the accuracy and validation accuracy. Okay, so that's it. So you notice, actually the graph looks so good. and then the let's save the model, the extracted file for that, for the training and the testing. All right, so let's save the model. And then let's save. Let's create also JSON file. Okay, so let me check in the Google Drive. Right, so I already have the save result of the model. So let's save the JSON file again. Okay, so as you see, we have the JSON file and the H5 file. So these files will be imported or embedded into your TensorFlow API in your Android Studio. Okay, so let's go back. So let's close the JSON file, and then it's, yeah. Now let's check our classification from the above training that has been done. So let's just check uh, the probabilities of our model. Okay, so let's import the image. Let's do sizing of image. So for as recommended, the model image size must be 32 by 32 by 3. And then if you notice, I have here a directory from which I will get my image for testing or for classification, just testing the generated uh, generated model. Okay, so here app 3, so in which I have put that in this folder. I have images for that will be classified. It's, so this is the image to be classified. Let's do the prediction. Okay, it's quite confusing because it's supposed to result to ISAP. Let's just change the image, because I believe because the images of Glenn and Isaac are really, they have really the same face. Let's just try another image. Uh, let me try. Okay, so for that image, let's try again. Okay, classification. Okay, so if you see the classification, it classified that this is the class ISAP with probability of 97%, while the second probability goes with 0.02%. Okay, for the class then, and 0.007% army, which is really a good result. Okay, so let's check another picture to validate. We use mine. Okay, so this goes to show that our model has been outperform or it has outstanding performance. Okay, as you see, the probability for the army class, which we can validate that this is accurate, so 97%. Okay, so if we